Go ahead and pause the video and try this AP problem by yourself. Restart when you have an answer. All right, so for A, first we need to read that beginning section. It says we have 5 identical balloons. They all have the same volume, the same temperature, and the same pressure. So if we have PV equals nRT, and the temperature is the same, the pressure is the same, the volume is the same, and our R is the same because that's a constant, then the moles also have to be the same. Since the moles are the same, and we're looking for the greatest mass, we just need to find the one with the greatest molar mass. So CO2 is roughly 44, oxygen is 32, helium is 4, nitrogen is 28, and methane is 16. Since they all have the same number of moles, due to the same volume, temperature, and pressure, the gas with the greatest molar mass would have the greatest mass, which is CO2. That's the answer that you should have for A to get full credit. So be careful when you have the same volume, temperature, and pressure. When they're saying things are the same, write Pivner and scratch out the things that are the same so you can see the relationship. Anytime volume, temperature, and pressure are the same, you'll have the same number of moles. Go ahead and try B, restart when you have an answer. So this one is talking about kinetic energy. Anytime you see kinetic energy, you should be thinking temperature because kinetic energy is related to the Kelvin temperature. Since all the balloons are at the same temperature and kinetic energy is directly related to Kelvin temperature, they would all be the same. Go ahead and pause the video and solve C, restart when you have an answer. We want the gas that deviates the most. Because they're all at the same conditions, we have to look at the gases themselves. Because we want the one that's going to deviate the most, we want the one that has the largest size or the largest IMFs. In other words, it's polar. All of the gases above are nonpolar. Because they're all nonpolar, we're just looking at size and we want the biggest gas. So the biggest gas would be CO2 because it would have the most number of electrons. So for a full answer, CO2 because it is the largest molecule. And because they are all nonpolar, the molecule with the greatest number of electrons has the greatest IMF. So when they're all nonpolar, we look at the number of electrons. We'll talk more about that in later units. We're going to pause the video and try this last one on your own. So if we want the balloon that's going to be the smallest, we want the molecule whose gas particles are going out the quickest, which means it would have the greatest rate of effusion, because effusion is the rate at which it goes through an opening. We base rate of effusion on molar mass. And previously, when we looked at the molar masses, we saw that helium had the smallest molar mass, and therefore it should have the greatest velocity. So helium would be the smallest because it has the smallest molar mass, which would mean it would have the greatest average velocity, allowing it to leave the fastest. CO2, having the biggest molar mass, would stay in the balloon the longest. That's why when you go and get party balloons, the helium balloons, if they're not in special Mylar or helium quality balloons, will deflate very quickly, while the ones that you blow up with your CO2 stay inflated for so much longer.